Guys, and we are going to just kind of go through this warm-up pretty quickly. So somebody, in your own words, so Katie, in your own words, explain what you do with number 1 here. Good. We have to follow order of operations, PEMDAS. So exponents, parentheses we don't have, so exponents first. So that exponent says that we are doing 2 times 2 times 2 times 2, right? So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we have 3 times 16. Then what, Katie? So 3 times 6 is 18. So 48 is your answer. All right, Jenny, number 2. What do you have to do first? The exponent. What does this exponent of negative 1 mean? Okay, so how is that going to look? Tell me exactly how to write it up. So that becomes 1/4. So this is like over 1. So that becomes 1/4. And we keep 5 multiplied out front. So what does your answer become, Katie? Or I'm sorry, Katie. Jenny. Multiply, share across. 5 times 1 is 5. 4 times 1 is 4. So this is just a recap from Monday. Kelly Kavanaugh, number 3.
We do the exponent first, but make it 1.
Anything to the 0 power is 1. So what does it become then?
It'd be 2 times 1, which is just 2.
Good. 2 times 1, which is just 2, because the 0 is not around the 2, right? The 0 is only around the 7. That's what those parentheses indicate. Okay, Jill. What about 4? It's just 1. Anything to the 0 power, this whole entire thing is to the 0 power, is 1, so it's 1. Avery, what would this one look like? Number 5. Be careful. So this is negative 2. So that means that does flip it. It becomes 2 over 1, but it still is to the positive second power, right? Once you flip it, the exponent becomes positive. The flipping of the reciprocating of something, Kaylin, I'm looking at you again. The reciprocating of something is what changes it from positive to negative, okay? So that changed it because I flipped it. So the 1 moved to the denominator, the 2 moved to the numerator. And since I flipped that switches the sign. Okay? So that's why it became 2. So then what would I have to do from here, Avery? Because that's technically what it would be. Right, so this would be 1/4 times 2 times 2, which is just 4, right? So we have 1/4 times 4, which becomes what, Avery? Which is 1. All right. Number 6, Mackenzie. So that becomes 2 over 1, which is just 2. So the 0 is not on everything. The 0 is only on the 3, right? It doesn't have that parenthesis around it like number 4 has. Number 4 has a parenthesis around the 1 and the 4, meaning that 0 applies to both the 1 and the 4. Whereas in 6, there's no parenthesis. It's only touching the 3. So technically, this has an exponent of 1. 2 to the first power is just 2. So that's why that's that way. All right, Hannah, number 7.
Since it's 5 to the negative 1, you have to bring that to the bottom. To be 2 to the first, 5 to the first.
And then what's in the numerator still then? 1. So what do you get then? 1 over 10. Alex, last one. So the top is the numerator, so we have 4 to the first times 5 to the first to make that, once we move it, the exponent becomes positive, right? The movement, the reciprocating, the flipping makes that positive. So that's what makes that exponent positive. So what's my final answer, Alex? Perfect. All right, so do you have any questions based on the recap? Because I wanted to go over some of this stuff with you guys since I was not here to teach lesson Monday. Any questions for me? If you're confused with this still, please come see me or let me check your homework assignments or whatever you want me to do to help you out to make this better for you, okay? All right, so let's get talking about what is an exponential function. So an exponential function is in the form f of x equals ab to the x power. You know something is exponential when the variable is the exponent. It is exponential. So when the variable is the exponent, you know it's an exponential function. So that's versus your guys' used to of the linear. So like if we just recap linear, remember linear, x and y are bases to the first power. Meaning there is no exponent. So make sure you guys can tell the difference between linear and exponential. The big difference is that if you see an exponent that's a variable, it's exponential. If it's linear, it won't have any exponents at all. It will have that y equals mx plus b, or y minus y1 equals m times x minus x1, or maybe standard form even, okay? So they don't have, you look at them, those x and y do not have any exponents. They have an exponent of 1. So that's the big difference. As for exponential, your initial amount is a, which is like in y equals mx plus b, which is like b in y equals mx plus b. It's your y-intercept. So that is your y-intercept. The growth factor is b, which is kind of like the slope. Growth factor is always multiplication. It might look like division to you guys sometimes, but that we can change to multiplication by making it a fraction. So it's always multiplication, whereas in a linear, it's always addition or subtraction. So that's the difference there. So this is kind of like the slope in y equals mx plus b. X is just your exponent, which typically is over time. It might be over a few days, a few weeks, a few months, a few years, but that's typically what it is in context. And f of x is your total amount. So that same concept of y equals mx plus b applies to this, but it's just a different form. It makes an exponential function, and we'll see what those look like. All right, so go ahead and get that stuff copied down, and then we'll look. See if you please ask questions if you have questions. So how to identify an exponential growth and decay from a graph. So first thing you have to do is determine the growth factor, if at all possible. If it is possible, you should be fine. So what makes something exponential growth? So let's first talk about that. exponential growth, which one of these do you guys think is exponential growth and which one do you think is decay, first of all? Which one do you guys think is which? One is growth and one is decay. Which one looks like it's growing and what decaying means going down? Yeah. Well, it literally says it for you. The one to the right is decay, right? Why? Let's ask this way. Why is it labeled that way? Why do you guys think it's that way? Jill?
Because it's going down.
This one's going down. So decay means down. Basically, it's going downwards. And growth means it's going up. It's getting bigger. So that kind of helps you there. So from a graph, exponential growth will start off slowly. And I want to say grow exponentially, but we don't want to say that. So we'll say and shoot off like quickly from there. So it starts off slowly and then it grows really, really quickly all of a sudden. So if you notice here, this is pretty slowly growing, and then all of a sudden it's getting really steep, right? So it starts off less steep to more steep. Whereas exponential decay will start off going down fast. Write this down, Kelly. And slow down. This is brand new for all of you. You did not learn this last year unless you were in Algebra 1. This is a new function for you guys, okay? So please ask questions. In exponential growth, that b value, when we were talking about y equals ab to the x, right? In exponential growth, your b value is going to be greater than 1. So that's the greater than symbol. In exponential decay, your b value is going to be between 0 and 1. So that's going to be between 0 and 1. So let's talk about, it says talk about determining the growth factor if possible. So what you need to do that is determine some points on your graph. But they have to be one after the other. So I'm just writing down some points one after the other. And we'll make a table out of it. So if you have 3 points, that should be enough. And make sure they're counting by ones, like you're stepping by one each time. Vivian, what do you notice is happening on our y? It's doubling, it's multiplying by 2. Is that bigger than 1 or between 0 and 1? Bigger than 1. So this is growth because the growth factor, so whatever you're multiplying by, because the growth factor is 2, which is bigger than 1. Okay, I'm going to do the same thing on the second graph. Just choose some points. So that's negative 220. Again, you have to do one after the other for the x. And then that's 0, 5. And I'm going to put them in a table. So I choose 3 points. Carly, what do you notice is happening to the y values? They're going down by 20. 20 minus 20 is 10. So what's a way we can call dividing by 2 multiplication? What are you multiplying by if you're dividing by 2? Kelly? So whenever you say you're dividing by the number, it needs to be a multiplication. So if you say it's dividing by 2, or dividing by 3, or dividing by 4, all that means is you're multiplying by 1 over that number. That's the same thing. So you just change it to that. So this is decay. Now, is 1/2 between 0 and 1? Yeah. So this is decay because the decay factor is 1/2, which is between 0 and 1. All right. So look at it from a graph, because we're going to do it from an equation, and we'll do it from a table in just a second here. But I want you guys to ask questions first. So we'll do this from a table and from a graph. We're going to do it from a graph, from a table and an equation next. Yes.
So say you like have a table and then you know like what we just did, how it's like dividing. So you would just like use the reciprocal to find the multiplication.
Yeah, so if you divide by a number, remember dividing by a number, if you're thinking about fractions, is the same thing as multiplying by the reciprocal. So yeah, you just reciprocate it. So whatever you're dividing by, just reciprocate it. Because exponential growth and decay always has to be in terms of multiplication. So division can be written as multiplication if you just reciprocate it. Okay. So how to identify exponential growth and decay from an equation? Remember, it's y equals ab to the x. We just said this. In exponential growth, b needs to be greater than 1. And in exponential decay, b needs to be between 0 and 1. So if you need to write that as greater than 1 for yourself, and between 0 and 1, so then we're going to look at these ones in the growth column. First, you're going to identify what your b value is for me, and then we'll talk about why it's growth. So Iris, in this one, what is my b value? If you're looking at y equals ab to the x, which one is your b value? 5. 5 is your b value. So you have to ask yourself, is 5 greater than 1?
Yes.
Yeah, so that's why this is growth, because 5 is greater than 1. Alexis, identify my b value in that second one there.
45 over half.
Where are you at? I'm still in the exponential growth column, sorry. The one below that.
2/3.
Is that bigger than 1?
Yeah.
Yeah, that's 3 and 1/3, right? So is that bigger than 1, guys? So, yeah, because 3 and 1/3 is greater than 1. Jacqueline, what's different about that last one there? 1, it doesn't have a number. Not a huge deal. We don't have to worry about that. What's another thing, Kelly? Negative exponent. You always have to look at things in terms of a positive exponent, so we need to change this. You cannot determine your b value until it is a positive exponent, so it needs to change to a positive. So this is like y equals, and I'm going to change that to 1/4 to the negative x. So what's 1/4 to the negative x get changed to? 4. Good job, Hannah. So that's y equals 4 to the x power, because you reciprocate it, right? Is 4 bigger than 1? So you cannot determine your b value until you have a positive exponent. You learned on Monday that that means a reciprocal. And 4 is bigger than 1. Okay, so let's look at the decay column next. All right. Avery, what's my b value in y equals 2 times 0.5 to the x?
1/2.
Okay, is 1/2 between 0 and 1?
Yeah.
So it's not that 2 that matters, it's the 1/2. Olivia, what's my b value in that second one? 2/3. So is that between 0 and 1? Uh-oh. What do you guys notice, Morgan, on this next one?
Negative exponent.
So we have to change it to a positive exponent, right? So what does that become then? So y equals 1/2 x. So what is your b value then, Morgan?
1/2.
Is that between 0 and 1?
Yes.
So does your a value matter when you're determining growth or decay? Does this front number matter when you're determining growth or decay? No, you're just looking at the base, the b value, which is your growth or decay factor. And you must have a positive exponent. So if you see a negative exponent, make sure you reciprocate that. So what questions do you guys have about doing things from an equation? We've done graphs and equations, so the next thing is tables. Okay, remember we said the b value is greater than 1. So you're multiplying, f of x is multiplying by a number greater than 1. In exponential decay, we said b is between 0 and 1. So f of x is multiplying by a number between 0 and 1. And that is going to be considered your b value. So look at this first one here for me. Jacqueline, look at that first one there for me. What is happening from one value, f of x value? Notice first it's stepping by 1. It needs to step by 1 on the x each time, so that's good. So what is happening here? So your b value happens to be 4. So if the b value is 4, that's bigger than 1, so that it is growth. So since 4 is bigger than 1, it is exponential growth. Okay, Spencer, what's happening on the next one there? It's stepping by 1 on the x, which is what you need. What is happening to the f of x? So we can't say divide it by. It always has to be multiplication. You are not incorrect, though. How can you write divide it by 5 as a multiplication? Yes. So if you're saying you're dividing, you are just reciprocating it. So you're multiplying by 1/5. So your b value is 1/5, which is between 0 and 1. So it's decay. Okay. I'm going to try to do one of the tables with you guys, and then I will get you your homework. Sorry, we're flying through here. Go ahead and get stuff copied down. I wanted to get you guys your tests back today, too, so... And I wasn't here Monday, so I wanted to make sure you guys were understanding stuff. Okay. You did some of this stuff, haven't you, already? You've seen this, haven't you? Didn't you do some of this stuff on the notes from Monday? Okay. So, all you're doing is substituting for x. So this becomes 2 times 3 to the negative second, right? Exponents first. We did that whole front slide, right? So that means that this is 2 times 1 over 3 squared. We're probably going to go into the thing. So that's 2 times 1/3. I'm going to make that 2 over 1. So 2 over 1 times 1/3 times 1/3, right? 2 times 1 is 2. 2 times 1 is 2. So that's a 2 on top. And 1 times 3 is 3. 3 times 3 is 9. So we have an ordered pair at -2 and 2 9. So that's going to be really close down here. So I'm going to plot that point there. I'm going to do different colors for each one so you can kind of see where that's coming from. All right. Next one, negative exponent. This one's just a reciprocated one. So this is like 1/3 to the first power. So essentially all we have is 2 over 1 times 1/3. 2 times 1 is 2. 1 times 3 is 3. So 2/3 is up there. All right, next one. Anything to the 0 power is 1. So this is 2 times 1, which is just 2. So I do 0, comma 2. 2 times 3 to the first power. Anything to the first power stays itself. So 2 times 3 is 6. So that's 1, comma 6. And then finally, 2 times 3 squared. 3 squared is 3 times 3. So that's 2 times 3 times 3. So 3 times 3 is 9. 9 times 3, or 9 times 2 is 18. So that won't fit on my graph. What shape do you notice this is making? When you connect your points, it is making a what? It's growth. It's a growth function, and it is a curve. So this is an exponential growth function. It is tripling each time. Very, very good.